Yeah. Yeah. So, good afternoon, everyone. Um, Today we're taking decision control and conditional statements in Python. CSE 201, computer programming. This is a 3 unit course, so please follow. So let's start with section 4.1, Introduction to Control Flow. When you talk about control flow, when you talk about writing a program, your program, when you write it, will run sequentially. So it runs from top to bottom without any interference. So as long as there's nothing to interfere with how your code runs, it runs from your first line to your last line sequentially. Now, that is what we are talking about here when we refer to normal execution. So instructions run sequentially from top to bottom. Now, there is a need for control. There is a need to attach control because it's not every code that you write that will how do I say this? There's not every code that you write that will run sequentially. Sometimes you will need to add a condition. Sometimes you will need to interrupt the code. Sometimes you need something to happen during you writing the code that will then, lead to another portion of the code running or something. So there's a need for control. And this is where decision control and conditions come into play. So now, real world problems require programs to make decisions, repeat actions, or skip instructions based on certain conditions. So let's go forward again. So, introduction to control flow, key concepts. So we have 3 different concepts that I need us to know. The main concept that we're going to be working on today is control statements, this one. But I need you to understand what conditional statements and decision statements refer to. Now, what is a conditional statement? Is a test that evaluates to true or false. Is a cat a cat? Is if you have a cat and someone says it's a cat, it is true, it's a cat. So is 50 greater than 1? That's a true statement. So it either evaluates to true or it evaluates to false, depending on the condition. We'll treat it further as we go. But when you talk about decision statements use conditions to choose which action to take. So the decision statements utilize conditional statements in order to make or to choose an action that follows in your code. So you can have a code that is written sequentially, X, Y, Z, and everything is written sequentially. But by the time you want to run your program using some form of control flow, you can have a decision that will skip a portion of the code, right? It will skip an entire portion of the code, depending on what conditions are fulfilled. So now, that is it shows us statement. I'm going to show you some examples. Now let's go to control statements. Control statements control statements, programming constructs are programming constructs that follow. Sorry, I need to reduce the screen here. Good. Are programming constructs that follow the flow of execution using the decisions and repetition. So we're going to touch on that. Now let's go to the next section. Let's talk about conditional statements first. It's a test that checks whether something is true or false using comparison or logical operators. Now, when you talk about comparison operators, is something equals to something, is something greater than something. You are comparing two things. So if you've ever dealt with logic like greater than or equals to, less than, those are comparison operators. But when you talk about logical operators, you are saying things like or, and, or these are logical operators, right? So you can have conditional statements that are a combination of comparison or logical operators. So you can say if x is equals to 5, or x is equals to 6 or something like that. So one of those two conditions. Or you can have different conditions that say if x is equals to 5 and and y is equals to 10 or something, perform this. So if that condition is true, run my code. Now, it does not execute code. It only provides a Boolean result. So remember, we're talking about a conditional statement. It's a statement that fulfills a certain condition and lets us know whether the condition is true or false. Now, let's go to conditional statement example. This is just straightforward. We have score is greater than or equals to 50. It simply checks if the value of the score is at least 50. Is it 50 or above? That is just a conditional statement. Now, you can have several other statements that say if score is greater than or equals to 50, or score is, less than or equals to something. So two of those conditions are fulfilled. Now, let's go talk about decision statements. So decision statements that use a condition to choose which action to take, deciding between different blocks of code. So like I said, your blocks of code can run sequentially, and you can have some form of flow within that can help you to skip portions of the code, maybe repeat portions of the code. So decision statements help you do that. And in Python, this include if else, if, even nested if statements, which we will get to as we proceed. Now, decision statement example, this is it. So now, if is a decision statement, right? This is a conditional statement. A combination of these provides the decision that we're going to print passed. So this is just an example saying if a student's score is greater than or equals to 50, just say the person passed. So now this program decides whether or not to print passed based on the condition being true. Now, let's talk about control statements, which combines everything that we have been discussing, that decision conditional statements. It combines everything. Puts everything together and allows you to utilize conditional statements, decision statements, and other forms of control statements that we have not yet discussed to control how your program executes, so it doesn't execute sequentially. Okay. So apologies. So now let's talk about capabilities of having control statements. It helps you to make decisions based on conditions. It can help you execute a block of code repeatedly. That's loops. So of course, we have discussed the rudimentary of this. When you make decisions based on conditions, that's what we're talking about, is conditional statement, decision statements. Now, interrupt or alter the normal sequence, right? So that is what control flow allows you to do. It can help you to interrupt the normal sequence of running a code. Like I said, you can have a sequential code, and based on a certain condition, based on a certain thing, you can skip portions of the code. But when we even get to talk about loops, you can repeat portions of the code. But now, let us talk about control statements. How do they all fit together? That is what control statements are. We have a conditional statement like this. Then we have a decision statement. Then we have, this is meant to be the entire structure, not entire if structure. So please note that in your slides. Correct it. It is a typo. Now, entire if structure, we have a control statement, then we have controls the program flow. So practically, if you are going to write a program before, instead of it's being executed sequentially, you can then put up a control program, a control statement that allows you to make important decisions, change the flow of your code. Now, let's go to categories of control statements. We have discussed conditional statements, we have discussed decision statements. We're talking about control statements, which simply embodies all these concepts. But now, let us go deeper into control statements, because the only kind of control statements that exist are not just decision statements. They are not statements that exist just, okay, just let me make a decision, and if this decision is right, skip it or not. We also have iterative control statements like loops. We have jump control statements like continue, pass, break. We have and decision control statements, which is what we've discussed earlier. But let us take all of them one after the other. Now, decision control statements allows a program to make decisions. Apologies. Allows a program rather to make decisions and so on. Okay. So decision control statements, they allow a program to make choices based on conditions that evaluates to true or false. So remember when we discussed conditional statements and decision statements, all of those concepts are embodied under decision control statements. So let's go to a simple example. We have an if statement like I've shown before. This is the simplest form of a control statement. So it executes a block only when a given condition is true. This is the syntax, how it is expressed in programming. You have if this condition goes to either true or false. So if this is true, it gives you whatever you have put down as your statements or your statements. It runs your block of code. It does what it does. It runs your block of code. So now, a broad example, a programming example. For instance, we can say, let's say you set a temperature variable. Let's say you want to check, is the weather hot? What's the optimal temperature for, the weather? So you can say temperature is equal to 30. And, you set the temperature. Let's say 30 is the optimal temperature for human beings to, this is the temperature that we like. Then we can say, check if the weather is hot. So this is the conditional statement we use to check it. So if temperature is greater than 25 or whatnot, print the weather is hot. You can set this temperature, but we know, my apologies, let me go over that again. Let's say your current temperature, right? I digress. Scrap what I just said, but listen to this. Let's say your current temperature is 30 degrees Celsius. That's what you have measured as today's temperature. But you want to know if the weather is hot. And we know that the right temperature, the proper temperature for us is like 25 degrees Celsius. Let's say that's just what we have in our mind. We can then say, okay, we have today's temperature as it being equals to 30. Let us check if the weather is hot. We know that the optimal temperature is 25. So we keep that 25. We need to just simply check a conditional statement. Is today's temperature greater than 25? That's it. If the temperature is greater than 25, so this is a decision, condition, and everything is a control flow statement. And you get the weather is hot. So if you set this to like 15, you will get something else other than that. So this is where we then get to things like if else statements, right? So let us say our temperature here was like 17. We will be getting something here, another condition that we can add to control the flow of the program. Now let's go to if else statements. It allows a program to choose between two alternatives, right? Like I discussed in the previous one, we have a temperature here that is not fulfilling what we want. So if this one doesn't fulfill what we want, how do we make a decision? What is the next decision? What's the flow? Now we can say one block runs if the condition is true and another if it is false. So now let us work on an example. Of course, the example has changed. It's no longer the temperature example, but still follow. So now let us say you set your variable to 4. Let's say you have a number. Someone says, guess a particular number. let's say you are playing a game and the person wants to know whether you are picking an even number or an odd number. So your number is equals to 4. You want to check whether that number is even or odd. So those are two conditions that you need to check. So you can say, okay, if the number, this is called a modulo operator, in case you don't know, or just do your research. If the number is modulo 2 is equals to 0, print the number is an even number. Just in case you don't know, a modulo operator simply divides or slashes a number by 2. If there's a remainder of 1, it tells you that that number is an odd number. If there's a remainder of 0, it tells you that the number is an even number. Even numbers are numbers that are divisible completely by 2, right? And odd numbers, we always have 1 left. So that's like secondary school mathematics. So this is how it is simply represented in Python. It's called modulo. So if a number modulo 2 is equals to 0, print even number, else print odd number. So you see the flow has changed. We have this decision statement, we have this conditional statement, we have our code that we want to run. If that doesn't work, we have another thing that runs. So instead of this code simply running even number as the result, odd number as the result, it then comes from the top, right? Reads, okay, this is the number we set, number modulo 2. It prints this, then skips this. If this number was 3, for example, it will simply skip this block of code, then come and run this. So you can see that that execution is no longer necessarily sequential. That is running everything, right? It is now running, it gets here, it skips this, it comes here. So that's just the basic idea of control flow statements. So now I want to announce the attendance codes. The first one, the first code, right? So please pay attention. The first code is G, like G, K, Y, 3, R. So this is G for like God or goal or something like that. So G, K, Y, 3, R. Is over. Okay, so you all have like 2 minutes to fill code. I'm going to call it again. G, K, Y, 3, R. So good evening. Let me know. You can comment, just comment if you have already filled or if you get the, yes, in capital letters, Gideon. Yeah, in capital letters. So someone can just comment, yes, in capital. So let me call it one last time. Just comment. You can put something like okay, good. So last time, G, K, Y, 3, R. Okay, very good. Someone has put it in your chat. So let's move on with what we're doing. So now this is if else examples, right? So we just discussed if else examples. So now let's move on to a different kind of decision control statement. So recall that we are talking about decision control statements, which is the first kind of control statement we're talking about. So this is just a more extensive discussion of what we discussed initially. So let's go to if, elif, then else statements. So if and elif, what elif means in Python is just else, if. So literally, it helps you to set another condition if your first condition is not true. So instead of automatically defaulting to, if this condition is not fulfilled, do this. You can have another condition that they may do. So if you go to if we talk about like the temperature one, and you say if the temperature is greater than 25, do this. You can then have another condition like, okay, and then have another condition. If it is greater than 30, do this, or if it's less than 45, do this, right? So you could have multiple conditions that need to be fulfilled. And this decision statement helps you to do that. So it is used when there are multiple conditions to check. Python evaluates conditions from top to bottom and executes the first block whose condition is true. So I need you to pay attention to this. It evaluates condition from top to bottom and executes the first block whose condition is true. So now let us go to an if elif example. So let us say we set this variable marks to 65. Let's say we want to grade students, right? We then say if marks is greater than or equals to 70, give the student grade A. So this is the student's mark here that we have set in a variable, right? In a variable. So is this student's mark up to 70? No. So this is not going to run. It skips this entire block of code and jumps to this one. So now we will go to else. If marks are greater than or equals to 60, give the student grade B, right? It does that and it gives the student grade B. Of course, now this code is a little bit funny or a little bit problematic, because if it then skips this one, it goes to if marks are greater than or equals to 50, it will give the person grade C. So of course, else print fail. So if none of these are fulfilled, it will give the person a fail. So that means if you don't get up to at least 50 marks, to give you a fail. Well, but there has to be some correction to this, because if you look at this code now, for example, we have the person's mark is 65. We have this mark being above 70 or equals to 70, give the person a grade A. If the person's mark is above 60, give the person a grade B. The problem is that this will replace this will replace this, and eventually it will print grade C4. So I will send an updated slide for this code, but just understand that in this place, we will have to combine a logical operator, right? So that it will have something like else. If marks is greater than 60 and less than 65, right? So that it picks the range. It doesn't just replace the year. So it picks the range, and it does the same thing for marks are greater than or equals to 50 and less than 60. So that it doesn't replace this. But just understand the entire flow of it. It allows you to, take decisions based on whichever one is true. Now, let's go to a nested if statement. A nested if statement is basically an if statement inside another if statement. So let us say you're checking multiple conditions and you don't want to use logical operators to, merge those conditions. You want to check them separately. That's where nested if statements come in. So you can have, if a condition is true, so if this person is doing CS201 and this person is a male, group him in this set, right? So you may not want to include those two conditions depending on whatever problem you are trying to solve during your programming exercise. You might want to separate your conditions. So you can nest another if statement inside. You can nest the entire else if block inside another if statement, right? So an if statement placed inside another if statement used when a decision depends on a previous decision. Are you understanding? So let's just take this rudimentary, quite oversimplified example, right? This is an oversimplified example. Let's say you have two conditions. Let's say you want to check if a person is a citizen and the person is old enough to vote, right? So you have a code to check if a person is a citizen and the person is old enough to vote. So you're going to set the age and citizen variable. So let's say you go and meet the person. Okay, what's your age? Are you a citizen? Then they give you this they give you this data. They say, my age is 22. I am a citizen. Now you have a code that runs that, because people can have different information. So you say if the person's age is greater than or equals to 18. So if the person is 18 or above, you then check if this is true. Then you move to another condition to check if that person is a citizen. So you say if the age is greater than or equals to 18, you then move, okay, is this person a citizen? If the person is a citizen, so if this condition is true, if this nested condition is true, print the person is eligible to vote. Otherwise, print the person is not a citizen. So of course, they are not eligible to vote. However, you want to also have something printed for this above condition. Like, okay, We don't even care whether this person is a citizen or not. We don't want to care about this condition if this person is not even up to 18 years of age. So if this condition is not fulfilled, all this block of code right here is completely skipped in the flow or in the execution of the program. It then jumps directly from here, skips everything here, jumps directly to this one, and prints the person is on the edge. So you can understand how you can use control flow statements to modify how your code executes. You can add conditions, you can change the flow. It doesn't just have to run and print eligible votes, not a citizen on the edge. You can skip all this by just simply using a decision control statement. So now that is decision control statement. We're moving to the next kind of control statement, which is an iterative control statement, right? So iterative control statements are simply called loops. So if you think about it, what is a loop? A loop is something that simply goes round in circles. It just repeats. It's just a repeating thing. It's a loop. It keeps repeating itself until something breaks the loop. But let's move on. Essential for tasks like processing lists. So lists are your arrays in what are called arrays in Python. So you can check that while you are listening. So essential for tasks like processing lists, counting, handling user inputs until a specific condition is met, right? You can do anything till a condition is met. This is very important until a condition is met, but we'll move on. So now let us discuss the essential concepts of a loop. What are the things that a loop requires to be a loop, right? In Python, at least in programming. First, you need initialization, right? Giving a variable a starting value before the loop. So let us say we have 100 students, right? There's like 1,000 of you currently on following the course. So let us say there's 1,000 of you and we want to perform an operation. Now that's a lot of people, right? Let's say we want to automatically decide whether you have passed. Let's say like the grading function that we wrote, right? Let's say you have passed or you have not passed or whatnot. We don't want to write that code 1,000 times, right? But we have 1,000 of you. Now, let's say somebody has been coding or has been marking or has been grading you and has graded like the first 200 people. Let's say we now write a code that can perform that loop, that operation. So loops are very interesting. Let me just give you this breakdown. A loop can, let's say we are trying to grade all of you. A loop can then help us to simply run that same code multiple times. So instead of us writing the same code for 1,000 people, right, we can just write that one block of code and tell the loop to keep running until it has exhausted all 1,000 of you. So that is the idea of a loop. But you need a starting point. We may not always want to start from the first person. We may want to start from the 200th person. Are you understanding? So we may want to start from the 200th person. We may not want to start from the first person. So this is where initialization comes in. You need to start. So if they have graded 200 people, we will start from 200. Do you understand? So now, initialization. Now we need a condition. Conditions decide whether the loop should continue or stop. Like I emphasized in this paragraph here, a specific condition must be met. So let us say we want to saturate 1,000 students now, for example, and we want to look for any student that is named Bio, right? So if the condition is met, if we find the students whose name is Bio, so say we have all your names, 1,000 of you, we have your names, we can just give that code to a loop. If name is Bio, stop. We have found the person we are looking for, right? Let's say maybe there's nobody else being Bio, right? So a condition has to be met. If that condition is false, remember, conditional statements are either true or they are false. So if we don't find Bio, if name is never equals to Bio, the loop will keep running for as long as it needs to run until it finds Bio. But now there's one loop that can run forever until it finds that Bio. And there's another loop that will stop depending on what you have given it. That's like the essential basic difference between a while loop and a for loop, which are loops that we're going to discuss in the next slide. So we have the loop body, of course, the block of code that we want to repeat multiple times. Now, the update. is changing the loop variable so the condition eventually becomes true. Now, you must understand, let's say you have 1,000 of you and you are starting from the first person, you are starting to run a block of code from the first person, right? Your loop will just keep going and looping, the same code on that first person. If there's no way to tell it to jump to the next person, are you understand? So your loop has to jump to the next person. It needs to move. So you're starting with the first student, needs to go to the second student, to the third student. So this is what is called updates. You can also refer to it in programming as like increments, right? It helps your loop move forward, or else just keep rotating around the first student. So that's just like basic theoretical introduction to it. And now let's go to the types of loops in Python. So we'll talk about while loop, right? Like I discussed earlier, there are two types of loops in program, right? We have the while loop, we have the for loop. This one will keep running until a condition stops it. If you don't put this important condition, it will run forever and use up your entire memory. You might have to actually shut down and restart your system. But this is used to run when the number of repetitions is fixed or iterating over a sequence. A sequence are just repeating, repeating values, or you have like a data structure like a list. So do check your notes. Some of the examples here are not robust enough, but in your notes, there are examples and there are, questions that you can answer, and you will see how you can iterate or and a bunch of things. So do try that in your spare time. But that's the difference between the two. So let's move on. A while loop repeats a block of code as long as that condition is true. This is the syntax. Like we discussed earlier, we have the initialization. You see while, remember, then a conditional statement. So this is the condition that determines whether this continues to be true. So we initialize, we say while, our block of code comes in, and we continue to update it. So practically this runs such that we start from this, it checks this. If this is true, it increments it, goes back again, and it just keeps going around. So now let us go to the example. We have the count is equals to 1. Let's say this is where we want to start from. Let's say we just want to, iterate through numbers, for example, and we want to start from number 1. So we initialize it. Let's say our count is equals to 1. This is just a variable we can decide to put. We say count is equals to 1. We initialize it. Then we move to our while loop. We say while, then we check this condition. Is this condition true? It is less than, is 1 less than or equals to 5? Yes, it is true. That means our loop is going to run. So it will print count. So it will print 1. Then we have count plus or equals to 1. What this operator means is simply count is equals to like count plus 1. So you can do that kind of thing in Python that just helps you to add to your existing value. Are you understanding? It simply helps you to add to your existing value. So it says print count plus 1. So what happens now is you have count, you have this condition is true. It prints that 1, then it jumps to this and adds 1 to this variable. So now this variable up here, this count variable becomes 2. It then checks again. While this variable is less than or equals to, this is 2, this condition is going to be true. It runs it again. So we have 1, 2, it adds 1, then this is 3. Then it checks again. It's going to be less until this condition and the increments continues to increase this till we get to like, so we get to 6. So by the time it checks, by the time this increases to 6 and it checks this, you find out that this is no longer true. Then it simply breaks. Are you understanding? So while count is less than or equals to 6, it's not true. So this is not going to run again. You have broken out of the loop. If we didn't add this condition, imagine we just said while count, number will always be true. It will continue running forever as long as your computer can take it. It will keep running. So now let's go to for loop, right? It is used to iterate over a sequence of a fixed number of times. Like I was explaining, there's like 1,000 of you going through the course. A for loop will take that 1,000 people and just walk within that scope. So once it has exhausted whatever is given to it, it breaks. unlike the while loop. But the way we want to explain for loops here, we're going to use something called the range function. Now, you shouldn't think about it too, much, maybe in terms of programming perspective. A range is just like a sequence, like from something to somewhere. So if you say a range between 0 and 1, or is 0 and 5, is all the numbers between that sequence. Are you understanding? That's basically what it is. So for loops also work with data structures like lists and dictionaries. Do check your notes for information on this, because those examples are not included in the slide. So now let us go to the for loop syntax. So this is basically the sequence. For a variable, right, in a sequence, run this, right? Run this. For loops are essentially different in Python, especially different from while loops. Now, the way Python works is that it has been updated in such a way that you don't need to necessarily start writing out, specifying, okay, this is the increments, count +1, plus it. You don't need to do that. If it's in other programming languages, you still need to include it. And the syntax is different. So if you go to something like maybe JavaScript, you have to write for, then you need to initialize, maybe you write 1, but then you write a condition, then you then put the increments like plus is equals to 1. So some of you have dabbled in programming languages will understand what I'm saying. But if you have not, the people who are in charge of updating and working on the programming language, the ecosystem really, I've simply simplified it to be something like this. So you need this keyword called in. It's an operator, in operator. So it checks if a certain value is in a sequence. Like I said, there's 1,000 of you. We have your names. Now, let's say instead of, okay, want to do this, okay, so for each student in that sequence, so want to check, okay, for name in a list of names, in a sequence of names, right? If it's a range of numbers that we have, right? Look at this is range 5. Range 5 produces all these numbers. So between 0, so the reason why we just have 5 here is because a range defaults to, the default way a range works is range into brackets 0, comma, whatever number you're going to. But it doesn't account for that last number. So it is your starting number to the number, everything between your start and your deciding number. But this should explain this to all of you very simply. So now let us say a simple example. For I in range 5. Range 5 usually is this list of numbers if we want to print I. So range 5 on its own is already like 0, 1, 2, 3, 4. So if you just want to go through the list, it goes to, okay, for 0 in range 5, print it 0. For 1 in range 5, print it 1. So just a very simple, bare bones, basic example just to give you an introduction to the concepts. So, and that is it for loops. And that is it for loops. Anyway, all right, so we're going to jump control statements, which will be the final aspect of what we're doing. So I want to announce the second code. Are you guys ready? So now, someone is putting up a second code. Someone named RYT6G. That's not the second code. Don't write that code. That's not the second code. That's not the second code. I'm seeing RYT6G. That's not the second code. Yes. Whoever that person is should stop it. That's not the second code. So in case you've written it, my apologies. So the second code is 3B LRN. 3B LRN. Let me say it again. Just if you have written it, if you have confirmed it, please, yes. So there's someone named Sam. So yeah, people are really, not M, N for Nigeria, not M. 3BLRN. So please don't until I announce any code, please don't write any code. Nobody is going to. So N 3BLRN. N Nigeria. I'm seeing someone writing L. I'm seeing someone writing M. N. All right. So now let's move on to the final aspect of the course, which is jump control statements. Jump control statements, as they are called, just help you to interrupt the flow of the program, right? So let's say you have a for loop or a while loop. Jump control statements allow you to jump and do a bunch of things, break a bunch of things. But let's use the slide. So statements used to change the normal flow of execution within a loop. So just note that jump control statements are used exclusively within loops. You can't use them inside if statements or decision control statements. They are used exclusively inside iterative control statements. So they are an essential part of iterative control statements. Are you understanding? Please, if you can take a note. That basic concept to help you to remember it. So there are three main jump control statements, which are break, continue, and finally pass. Break, continue, and pass. So let us look at what break does. Break statement immediately stops a loop. That's all it does. It will stop the loop from running. Shaken now. So like you have an image or you have a range running, depending on a condition is met. Okay, stop at this. Let's say you have 1,000 students and you want to do only 200 students. Let's say you want to grade only 200 students. You write a simple code. If this person's score is greater than 20, give them grade A or something, right? And you want to do that for the first 200 out of 1,000 students. You can just simply include a break statement at a condition where, okay, if this person in this range of students is the 200 students, end it here, break. That is just what it is. So now, for I in a range 1,6. So range 1,6 will print 1, 2, 3, 4, 5. If I is equals to 4, so if we do for 1, for 2, for 3, for 4, by the time we get to 4, by the time I is equals to 4, we want to stop it. We don't care about number 5. We want to stop. This is how we're going to execute that. So we start from checking each of the range, iterating over the range. We check the condition, we print it. Then if I is equals to 1, it doesn't interrupt. It goes again, it loops again. If I is equals to 2, it loops again. If I is equals to 3, it loops again. If I is then equals to 4, it prints it, then it ends the loop. And we get this result, 1, 2, 3, 4. That's necessarily how a break statement works. Just understand the simple, very rudimentary example. Now, let's go to a continuous statement, right? A continuous statement is used to skip current iteration, then move to the next. So our previous example was for I in range 1,6. So let us say, there was someone that was dropping some fake code on the chat. Let's say we want to implement some kind of discipline for this person now. What would you do? We'll say, let's keep him, don't let's grade him, right? So now let's say this person is number 202. We want to then include some kind of code in our program that, okay, you have started from person 1, you have graded person 1, person 200, person 201. By the time you get to this person 202, just jump over him. Just keep him, leave him, so you can simply eliminate and separate, okay, this person, the code should not run for this particular person for this particular reason. So you can, of course, imagine different other ways that you can do that kind of thing. Okay, so now let me just push that. So we have for I in range 1,6. If I is equals to 3, continue. It will print I, right? So remember, range 1,6 is 1, 2, 3, 4, 5, right? It doesn't print 6, right? So we have 1, 2, 3, 4, 5. That is what this range means. So as we're going through, we have if I is equals to 1, does it continue? No. If I is equals to 2, does it continue? No. But it keeps printing, it keeps printing, it keeps printing them. But by the time I is equals to 3, it just skips, it skips this person, then jumps to the next one. So you have a result here 1, 2, 3, 4. Just jumped over person 3. Are you understanding? So continuous statement alters the flow of the loop when the condition, if I is equal to 3 is met. It is 3 in the range is skipped. So now let's go to pass statements. Let's go to pass statements. Now the pass statements, okay, good. We're almost done. So now the pass statement is a null statement. It does nothing when executed. So if you have for I in range this, for I is equal to 3, it just passes it. It still returns your entire range for you. Pass does nothing and allows execution to continue to the next line. Now you may be wondering, what is the relevance of this? But it is relevant when you are writing code. Let us say you are building your flow of, let's say, this 1,000 students who you are grading, but you have multiple conditions that you are writing for. Okay, if this person's name is this, if this course is this, has this person registered for the course, and you have different codes that need to run, right? If based on different conditions that are happening, or you are looping or whatever you are doing, but you don't yet have the logic, you don't yet have that code written, but you don't want it to alter the other portions of your program that you've written. So you can just put a pass for now, like, okay, I'll come back to it. If it gets there, just don't do anything for now. So this is a very, and I think it's one of the most important jump control statements that you even use. Apart from if statements, this is or for loops, this is one of that you are going to use most of the time if you program, because you need to, like, okay, I'm not done with this portion of my code. Just comment it out, put pass, so that once you are running and you're testing your code and you're debugging, it doesn't interfere with the normal flow of your code. Do you understand? So that is control statements in conclusion. So break terminates the loop completely, skip, continue with skip the current one, does nothing, pass does nothing, it's just a placeholder. So let me call the final attendance code for you. So are you all listening? So KRC86. It's a lot of jokers on this thing. Please, whoever is additional, Steven. Code 3, KRC86. Okay, so people have already started doing it. Yeah, KRC86. So that's the conclusion of control flow. It's fundamental to writing intelligent, efficient programs, mastering decision and iterative statements, and very input. So please go and read your notes. The notes have a lot more detail than the slides, or you can use the slides to read the notes and treat the questions that are inside the notes. So yeah, have a wonderful day. Okay, please submit your attendance. Said your attendance. Should school email be yes, Mav Wonder KRC86 is the third code. Yes. KRC86. People are still asking what's the KRC86. Someone said the email. Someone's asking all these questions like this one. I don't think.
What is that? Is the link now? This is the link that you use to submit, not what I did. So,
okay. So if you're asking, the link isn't working. How's the link not working? The link was shared, right? And I've opened the link and it's working. It's working fine. The link is working. The The link is working. The third code, KRC86. So some of your colleagues are already writing it. So the link is working. KRC86.
Wow. Yeah.
Some of them are saying it's not working. Let me first mute this people.
Others are submitting now. I see that they're submitting here.
So people are submitting. People are submitting. Okay, please ask your colleagues to share the link that they are using to submit to you. Maybe you are using another link or an old link or something. Then go and check your class group. It was shared already. I think some of them are just joking. All right, so have a nice day. So, yeah.